In these 4 seconds, 100 kilograms of textiles were thrown away in Australia. Over a year, this amounts to more than 800 million kilos of textile waste in Australia alone. Of all the textiles we throw away, only 7% is captured and recycled, making it by far the worst waste stream in terms of recovery rate in our country. Not plastic waste, not food waste, but textile waste. This has a devastating impact on our marine and land environments, contributing to 20% of global water pollution and 10% of global carbon emissions. This is why we at Enactus Australia set out to solve the Australian textile waste crisis. My name is Raghav. I'm joined by Emma, Amna, and Jessie, and we're here to present our startup, Circle.
Our mission started with an obsession to learn as much about the problem as possible. We wanted to make sure that we were targeting the core issue and not just treating a symptom. And so we started at the epicenter of textile recovery efforts in Australia, charity shops. We conducted over 80 interviews from volunteers to the CEO of Salvos, basically anyone that would pick up the phone and help us learn. And we soon uncovered a shocking truth. Only 15% of textiles that charity shops received can be reused again. The remaining 85% are at the end of their lives and destined for landfill. We began to understand that something deeper was going on, and so after speaking to repair shops, upcyclers, councils, and textile manufacturers, we identified our first key insight. In Australia, all end-of-life textiles are destined for landfill.
We wanted to dig deeper to figure out what was going wrong. Why can't our textile recovery efforts do anything about an end-of-life textile? We soon discovered a common flaw. All of our current solutions are focused on making the textile serve its original purpose as a fabric for as long as possible. This overlooks a crucial problem. Fabrics degrade over time. Eventually they reach a point where nothing can be done to make them usable. Whilst old jeans might be useful as a tote bag or a shrunken t-shirt can become a rag, ultimately they will end their life as a fabric. This was our second key insight. All current solutions focus on making textiles last longer as fabrics where they eventually end their life in landfill.
So how do we overcome this? Whilst textiles at the end of their life are no longer valuable when viewed as a fabric, they're still incredibly valuable if viewed as a resource. Think of the clothes in your wardrobe. Cotton, wool, silk, polyester. These are incredibly valuable resources when used as the inputs for new products. This was our third and final key insight, that Australian textile waste is a resource goldmine. We had to view textile waste not as a fabric, but as a resource goldmine. We had to create a solution that didn't just extend the life cycle of waste, but gave it an entirely new one.
So with all these insights in mind, we needed a solution that was able to break down a textile into its fundamental materials in order to rebuild it again into something new. And this, we realized, is only possible with a chemical process. So we partnered with the Bioperia Institute, a chemical engineering center at Monash University, to help us interrogate several chemical recycling technologies. Our scientific journey began in early 2022, where we tried to turn textiles back into fiber. However, as we progressed in our research, we realized that at scale, the unit economics of this process simply did not add up, and there were other technical limitations to achieving this. This meant we couldn't build a truly revolutionary business with this as our core process. So after many sleepless nights, pivots, and failed experiments, we've finally landed on what we believe is a groundbreaking innovation. I'm proud to present C-Plast. C-Plast is a revolutionary technology that turns cotton and cotton polyester blended textiles into biodegradable plastic.
Our technology can be broken down into 3 main processes: dissolving, regenerating, and bioplastic production. We start with a textile and combine it with an environmentally friendly and reusable type of liquid called an ionic liquid. When this powerful dissolving agent interacts with the fabric, the fibers break apart, dissolving it and preparing it for the second stage of our process. With mixed blend fabrics, this process selectively dissolves the cotton, leaving the polyester as an undissolved solid, which can then be recovered and recycled.
In the second part of our process, we then manipulate this dissolved mixture and subject it to various conditions to allow us to regenerate it and give it a completely new structure. What once was a fabric has now taken a form that can be used to create our product.
Finally, we further process this regenerated material to produce our bioplastic product. With a slight tweak in production methods, we are able to create a bioplastic with significantly different properties. For example, heat pressing creates an extremely rigid and sturdy material, whereas simple UV exposure produces a bendable plastic.
So now that you understand our process, let's discuss what makes C-Plast so incredibly groundbreaking. We've developed a way to continuously reuse our ionic liquid input such that we can exponentially decrease our operating cost. By using a simple liquid separation technique, we can reuse nearly all of the ionic liquid without losing any of its potency. In the lab, we've shown a 93% reuse rate. But what does this mean? Well, if we follow the math, a typical ionic liquid costs anywhere from around $2,500 per kilogram. With our process, after 10 iterations, we can bring this cost to below $300 per kilogram, and after 50 iterations, we can bring this cost to around $60 per kilogram. That's a 98% reduction in costs as a function of our revolutionary process. This is what gets us so excited about C-Plast.
Our second game changer is our ability to recycle mixed blend fabrics. This process allows us to capture and recycle up to 75% of all textile waste in Australia, enabling us to truly tackle the textile waste crisis.
Our third and final key innovation is our product. Cellulose bioplastics are a category of plastic alternatives that have sparked global interest for two key reasons. The first is their nearly identical mechanical properties to traditional plastic. And the second is their particular excellence in high-stress environments, such as extreme temperatures. So if this material is so good, why don't we see it being used everywhere? Well, bioplastics are held back because of one key commercial obstacle: high production costs. This is because conventional inputs for this bioplastic require extensive material sourcing and arduous chemical separation techniques. However, we at Circle are able to leapfrog this financial hurdle through the use and recovery of our ionic liquid. Conventional cellulose bioplastics cost around $3.76 to produce 1 kilogram. But with our initial cost modelling, we project that at scale, C-Plast will produce bioplastic at $2.95 per kilogram. This gives us a 22% cost reduction, priming us to capture a global market opportunity valued at over $2 billion. Our product has already gained some early customer interest, including the global packaging company Aurora. Our business model will serve companies like Aurora by providing them with the bioplastic for them to then further develop into their final products. This initial customer scoping has indicated that we can expect a price point of around $4 per kilogram of our bioplastic. This gives us a gross margin of 35%, where we're passing on our cost savings to our customer. And if all of this wasn't enough, our product represents a true closed-loop solution, being both fully recyclable and 100% biodegradable.
At this stage, we've de-risked all existential threats to C-Plast through our rigorous technical testing. You're not just looking at a team with an idea, but a team with a proof of concept that we can conduct C-Plast at a laboratory scale. We hope to test the scalability of C-Plast in our pilot program. We have $75,000 in grant funding expected to hit within the next 12 months, which will help facilitate the establishment of our own laboratory. And with an intellectual property agreement already in place with our current lab, we're ready to take this next big step in our journey.
But this is really only just the beginning here at Circle. Whilst most recycling companies fail because of suffocating input and operational costs that don't scale, we've instead opted to specifically innovate around this cost problem. This is our moat. And whilst we're confident we can seed into new recyclable markets, this isn't enough for us. We don't just want to be the best renewable alternative, we want to be the best product altogether. We don't just want to be the paper straw, we want to be the electric vehicle. Now this is all a lot to take in, but if there's anything we want you to take from today's presentation, let it be the following 3 things. Number 1, we've innovated to solve the core problem at the heart of textile waste, not just addressing a symptom. Number 2, we've innovated specifically around our cost so that our business model scales. And number 3, we're technologically, commercially, and legally primed to take our next phase of growth out of the lab. Everything we do at Circle is built with sustainability in mind, which is why we address the following 6 key United Nations SDGs. What we're building at Circle gets us so incredibly excited about the future, and we hope it gets you excited too. Thank you so much for listening, and we look forward to taking your questions.
Thank you for your presentation. We will now begin the question and answer period. Only judges may ask questions at this time.
Thank you for the presentation. I guess your project is considered like a scientific breakthrough. So have you thought about registering your idea, or it's like already registered since universities looks like they are investing in it?
Yeah, I'm happy to take that one. So before we started any experiments in the lab with Biopriya Institute, the one that we're partnering with, we made it very clear who owns the IP and had agreements signed in place with the university and the institute as well. So regarding the IP, it is 100% protected by us and we do own it. And we are currently in the process of registering our company and then under that protecting our IP as well. So yeah, that's currently in the works, and we've definitely done the work at the start to make sure that we protected our idea before we went into the lab and started engaging with different experiments and PhD students and chemical engineers. So yeah.
Thank you for that. You've partly answered my question on registering it as a company. What about the sustainability of it? Do you have any plans? Have you made any plans to put in place to ensure that the company is sustainable?
Yep, so all of us, as we mentioned, we are in the process of incorporating. So all of us, after our tenure at Enactus, will continue on in the business as employees or founders or directors. And we also have a really robust system to ensure that new students are coming in. We've built that sort of funnel that works really well. But yeah, this team, I think I can speak on behalf of all of us that we love this project, so we're going to stay on as the company is incorporated.
You just answered my question. Can clearly see why somebody would invest in your project. My question was, and you can answer it differently, why would they invest in you as a team?
Sure, yeah, I think there's a few reasons. I think one is we've worked on this project actually for about 3 years now. We have such a deep understanding of the problem, the people in the space. We're really invested in this, and so it's really just our passion and our expertise now that's driving this project. I think also from a team perspective, we're super multidisciplinary. So myself, I study law and science. We've got a bunch of other law students in the team. We've got engineers, we've got commerce students, we've got really the whole bunch. And that's what makes us, I think, unique, because we can attack this problem from all different angles and not just simply from a scientific or a business perspective.
Congratulations and thank you for the presentation. Regarding sustainable positive impact, it is clear how you directly impact on the environment. Do you plan also to have an impact on people?
Yeah,
yeah, sure, I can take that. First of all, congratulations on the cycling journey. We saw you at the finish line, so congrats. Yeah, so the way that we impact people is the main kind of textile recyclers, or the kind of ones who deal with the waste, are charity shops in Australia. And so they spend around $14 to $15 million every year just getting rid of these textiles that they can't sell. So the fact that we can take it off their hands free of charge and recycle it and create new products allows them to spend this $15 million on things that they actually want to spend it on, which is helping the most vulnerable Australians. So that's really how we impact the people in Australia through our product.
And just to tack onto that, there's also, we really want to look into, as we sort of wrap this process up from end to end, from cotton or polyester to bioplastic, we want to sort of wrap it up into a microfactory and be able to go and deploy this in different countries, maybe developing countries, train them on the job with some of these soft skills. There's a few of us that have no technical background that have been in the lab learning this process, so it is something that you can deploy in these developing countries, employ people, upskill them, and then obviously have, like you mentioned, the more sort of environmental sustainability impact.
Regarding your partnership with Aurora, when are you expecting to start the first production phase?
Sure, I can mention that. So the next phase of our growth is that factory that we were talking about, that kind of very first large-scale factory that we can create this product in. Essentially what we're waiting for is the grant money to hit through the public funds that we're looking at through the government. So as soon as we do that, we're able to produce this at a scale which we can begin kind of that commercial testing with Aurora. I think the first thing is like essentially testing it in their environments with the type of outputs that they want, and then we'll look to kind of expand that even further, maybe work with their manufacturers and their bodies to create that and and scale that beyond that. But essentially, we're waiting for that money to hit, and then we can create that factory, build it out, and scale our process.
Just a quick one. In addition to that, have you estimated how long it's going to take you to build this plant and for you to start production?
Yeah, I can take that one. Yeah, so no necessary time horizon that we're aware of, but we need the money in order to then take the sort of, we've created the process with our partner Biopriya, and now it's basically, we've done sort of an early...
Your time has now expired. Please join me in congratulating the team from Enactus Australia.